applications of vectors, or the famous river question, or the famous airplane crosswind question. Nice applications. Spoiler alert, they're both the same situation. An observer is standing on the shore of a river which flows to the east. Oh, well, I'm drawing a compass rose since they mentioned a compass direction. He sees a boat traveling across the river. The boat is pointing due north, but the current gives a resulting velocity of 8 meters per second, 65 degrees north of east. North of what? East. I'm going to dulp. Okay, so here's the river. And since they gave me lots of room, I'm going to do a fairly big picture. Which way does the river flow? So I'll make a little note here. Current. All right. The boat is pointing due north, so don't write this down. The boat is pointing this way, which means its engine is pushing it that way, but of course the river is also pushing it sideways, so the observer on the shore sees it kind of crabbing sideways like that. Rachel, does that make sense? You got to use your imagination a little bit. What is the resultant velocity? 8 meters per second at 65 degrees north of east. North of what? North of what? Okay, I'm going to draw that. I'm going to go east first. I'm going to go 65 degrees north of east, which is probably about there. 8 meters per second at an angle of 65 degrees. Did I say angle? Components. So another habit, Logan, that you'll develop. If we have an angle, 99% of the time, one of our steps is going to involve finding the components of that particular vector. So let's find the components of this vector. You know what? I'll draw it over here nice and big. So here's the 8. D. There's Vx. D. There's Vy. Before I dive in and find the components, let's look at part A. Alicia, what's part A asking me to find? What's it really asking me to find? Can anybody see? Isn't that the current? It's Vx in my diagram, but the only thing that's pushing sideways is the river. So you know what? It's saying find the current, but the current is actually one of the components. So I'm going to find Vx, hypotenuse adjacent. Yes, you are correct. Someone said it wants me to find the adjacent, Francesca. You're right. Alicia, which trig function? Very good. Got a couple latecomers. Times the 8 over. Vx, which is the current, ends up being 8 cos 65, 3.38 meters per second. Okay. B. How fast is the boat moving across the river? What's that really asking me to find? Yeah, Vy. Because that's the one that's going straight across the river. Opposite sine, I think. Yes? I think it's going to be sine of 65 equals Vy over 8. Vy is going to be 8 sine 65. 7.25 meters per second. By the way, don't memorize, oh, Vx is current. If the river was flowing north-south, then Vx would be how fast the boat was going across the river, and Vy would be the current. So I can always just flip things over. But yeah, the two components of the slanty vector are telling me an awful lot here. See, if the river is 256 meters wide, how long does it take to cross the river? You know what? I'm going to dulp some more still. So 256 meters, that's right here. Okay. Oh, and what? Is there a question, Logan? You're just playing with your calculator? Okay. Owen, what's part C you want me to find when it says how long? Time. And I think I told you last year, how long is a bit of a vague phrase, because in English, how long was the movie means time. How long is a football field means distance. So you kind of got to read the context. So it definitely wants me to find time. So here's important note number one. For both the airplane in a crosswind and the boat going across the river, we're going to assume A equals 0. I could do one with you with accelerations. It's doable. In fact, aside from my late students, we opened up today doing a vector acceleration with that 3 meters per second south at 4. We could handle it. Nah, I'm just not going to bother. It's overkill. So for all of these, the river question and the airplane question, you can assume A is 0, which means, I guess, I'm going to go D equals VIT plus a half AT squared, and the A is going to vanish. Remember that from last year? We'll be doing a review of these equations tomorrow, but I'm sneaking it in right now. We flogged that pretty good last year. Except, if there is one key concept today, your directions have to matter. You can't do math with a slanty velocity and a vertical velocity, or a slanty distance and a vertical velocity, or a horizontal acceleration and a vertical velocity. Your directions all have to matter. So look at that distance, that 256. Let's go back to our drawing. I'm going to argue this is a vertical distance because it's straight up down. Spencer, put your phone away. Yeah. Quickly, buddy. Okay? So I'm going to argue that this is actually dy, and because that's vertical, this has to be vy times t. Not vx, not v slanty. By far the most common mistake. Kids want to use that 8, and I'm going to tell you right now, when we're actually doing the physics, we will almost never use the slanty one. If you give me one with angles, components. Is it really important? I don't think it is. Okay, so you can put your phone even so you're not distracted if you want. Owen, what did you say I'm trying to find? How would I get the t by itself? Divide by what? Yeah. The time to cross is going to be the vertical distance divided by the vertical velocity. It's going to be 256 divided by 7.25. And I think I still have 7.25 on my calculator. So I'm going to go 256 divided by answer button just because. How long will it take to cross? 35.3 seconds. But here's the problem. That'll get you across. I'll scroll down in a second. But if you left here, if you wanted to end up there, you're going to end up down here somewhere because the river's pushing you sideways. So, D, How far down the bank will the boat have moved when it reaches the far side? That's a good question. I think, well, how far? Parker, what's D asking me to find when it says how far? Okay. I'm going to draw it in my picture. I think it wants me to find that. And I'm going to argue, hey, that's a dx, which means anything that I use to find that had better be horizontal, not using the 8. Again, a is 0, so I'm going to start out with d equals vt, dx equals vxt. Folks, what was vx? 3 point something, I think, wasn't it? 3.38? I don't know the time it went sideways. Or do I? Isn't the time that it took to go across the same amount of time it was drifting downriver? That's why I had to go in this order. So I can use 35.3. I'll use my answer button because it's sitting on my calculator. 3.38 times answer button. 119? Yep. Is that okay? E. Manraj, what's the boat's engine velocity? Too slow. Malcolm, what's the boat's engine velocity? Too slow. What I'm saying is you should already know the answer. No, otherwise it wouldn't be going anywhere. Nick, what's the boat's engine velocity? Yes, it is. Yes, you know. No. Can't be 8 because 8 is the combination of the river. It's a resultant. What? Yeah. That's the river. What's the boat's engine velocity? You also notice I didn't give you any room to work it out for a reason because you already know it. Shay, what? That's Vy is the engine velocity. That's the boat pushing it forward. That's how boats work. Got to imagine the little boat motor. So the engine velocity, V engine, in this case, it's Vy. What was it? 7 point what? 7 point? Sorry, say it again. 7.25? Okay. And let's suppose, as we say in boating parlance, it's WOT, which stands for wide open throttle. That's the fastest the boat can go. Okay. F. Suppose you want to land directly across from the starting point. In other words, supposing you don't want to end up down here and then have to schlep your way back. So instead, supposing you want to end up straight across, what will you do? Well, don't write this down. It seems to me you'll have to point the boat that way into the current. And it's going to look a little bit funny because the boat is going to be pointing like that, but it's going to be traveling like that. This was easier before they built the Golden Years Bridge, because before they built the Golden Years Bridge, every one of you would have gone on the Albion Ferry once or twice, and you would have seen that the Albion actually did that. To get straight across, it pointed itself at an angle upriver, and you kind of drifted crab walking all the way across. But sadly, the Albion is gone. It's also just a free boat ride. It's kind of cool. Also just meant you were going to be waiting for an hour, so it wasn't efficient, but free boat ride. But you see the argument? So here's what I'm going to say. It says, what direction should you point the boat? And what will the resultant vertical velocity be? I'm going to dulp, and I'm going to argue that I'm going to point the boat that way. Okay? Kessler asked a question. What did you ask? Is it the same angle? No. And the reason it's not the same angle is this slanty arrow, that's the boat motor. This is V engine, it's 7.25. Okay? What else is acting on the boat? Okay, so we also have the current. I'd like to combine those. How can I add those together? Draw them. Now this is going to be a weird triangle. It's not the one you're used to because now we're adding a slanty to a horizontal. But here's the important thing. I know what the resultant is supposed to look like. Do you know what the resultant is supposed to look like? Straight up. So tell me when to stop drawing the current. Not here. And not here. Because I know what the resultant is supposed to look like directly across from its starting point, I know that the current is going to look about like that. What was the current? 3.38. This here is the resultant. Now it's a little weird because this time the resultant is not a hypotenuse, but first of all, it asks for the direction. I guess theta is going to go here, color, 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 color. 3.38, opposite, adjacent, or hypotenuse? The 3.38? Opposite. 7.25. Which trig function to find the angle? Not tangent. So when somebody said, is it always going to be tangent? I said, well, as long as I keep it easy, but this is not an easy question. What trig function? Sine theta equals 3.38 over 7.25. Parker, if you can wait till the end of this question before you have to go, that'd be great. We're almost done. How big is theta? Shift sine 3.38 divided by 7.25. I think you forgot to hit the shift button again. 27.8. We'll go to 3 sig figs. North of south, east of west, what of what? Ooh, I've turned the page. I'm going to put a compass rose here. West of north. Yeah, it must be west because the current's pushing you east, so you would have to point the boat west somewhat to cancel out the current. Is that all right? And then B said, what will the resultant vertical velocity be? We can find the resultant. It's going to be Pythagoras, but I'm not finding a hypotenuse. My equation is going to be resultant squared plus 3.38 squared equals 7.25 squared because we're not finding a hypotenuse, we're finding one of the legs. Remember way back when we did our math review, we said you had to remember that c squared was always the hypotenuse, not the x. So I'll minus the 3.38 squared over. It's going to be 7.25 squared minus 3.38 squared, square root. If you want a direction, north. How long would this take to go across? Well, the distance across was 256, which was vertical, and this is also a vertical velocity, so I can plug it into the equation. It would take a little longer, it'd take 40 seconds, but the extra few seconds would save you having to schlep back 100 meters. So you'd probably, this is what most people would do. You point your boat into the current, so you have to walk less distance. You want to end up where you want to end up. Or if you're an airplane getting pushed by a crosswind, you point your airplane into the wind so that you actually end up at the city you want to land in. You don't want to end up far away from the city, turn, and have to fly into the wind to land at your city. So the key idea If they give you a vertical distance in your picture, make sure you use a vertical velocity to find time. If they give you a horizontal distance, make sure you use a horizontal velocity to find time. This year, you must pay attention to directions. All of the values that you're plugging into an equation, if any of them are vectors, they have to be pointing in the same direction. They have to be lined up with each other, which means you'll almost never be using one of the slanty ones to find something. Oh, unless they're scalars. Okay, Parker, that was example 1. If you need to go now, you can. Example 2. An observer is standing on the shore of a river that flows to the south. He sees a boat traveling across. Same as the first question. Oh, the boat's velocity on the river is 12 meters per second at 55 degrees east of south, and the boat is pointing due east. Okay, I'm going to dulp. What's the boat's velocity? 12 meters per second at 55 degrees east of what? East of what? East of what? First of all, I'm going to do a compass rose because I've turned the page. I guess I'm going to go south, east of south. And this is 12 meters per second, 55 degrees. Which way do you think the current is flowing? North, south, east, or west? Which way is the boat pointing? So if the boat is pointing that way, but we're ending up with that path, which way must the river be pointing? The river must be pushing it south. Is that okay? So now I can draw my river. Here's my river. It's a north-south river. And I'll make a little note. The current is south. Okay. It looks like the boat is moving 12 meters per second at a 55-degree angle. Did I say angle? Components. I'll call this Vy. I'll call this Vx, color. By the way, which one of these will tell me the current, Vy or Vx? Vy. Which one of these is the boat motor speed? Vx. That's the engine speed. Okay? Is that all right, Deegan? I mean, it's basically the previous question flipped sideways, and I gave you a little bit less information and made you have to figure out a bit more. So how fast is the current? Which one is the current? Let's label my triangle. Opposite, adjacent, hypotenuse. Which trig function is Vy going to be? Cos 55 equals Vy over 12. Vy, which is V current, is going to be 12 cos 55. 6.88. How fast is the boat moving across the river? I think that's Vx, which is going to be sine. And I'm going to make a little note. That's going to be the engine velocity because that's the boat motor pushing it as well. So I don't forget. 9.83. If the river is 320 meters wide, how long does it take to cross the river? So again, this is asking me to find time. Again, we're going to assume A is 0. D is 320, but I better figure out what direction this D is. So let's go back to my picture. I think the 320, I think that's a dx, a horizontal distance. So down here, I'm going to put a little dx, which means I better use a vx to find time, not a vy and not a v slanty. I'm going to use the 9.83. In fact, I'm going to use my answer button. Oh, and how would I get the t by itself? Oh, sorry. Let's write out the equation. It's going to be dx equals vxt. What happened to the plus a half at squared? A is 0. Oh, and how would I get the t by itself? Divide what? There we go. Having a little deja vu? Having a little deja vu? Okay. Having a little deja vu? Oh, sorry. Cheap joke. It's going to be 320 divided by 9.83. Divided by, haha, answer button. And I get 32.6. Of course, if we do it this way, we'll end up way downriver from where we want to go. How far downriver? Okay, I think that's asking me to find a vertical distance or displacement. dy equals question mark. A is still 0. I'm going to use Vy, which was, I can't remember, 6.88. And I'm going to use the time value from the previous. All right, 32.6, but I'm going to use my answer button. So it's going to be D equals VIT plus a half AT squared. Again, a half AT squared vanishes, so then I can argue since A is 0, VI is VX. Oh, wait a minute, Mr. Dewick. VY. It's going to be 6.88 times 32.6. And I get 224. I don't want to have to walk 224 meters back to get where I started. So let's see if we can figure out which way I should point the boat. First of all, what's the boat's engine velocity? I already know it. 9.83. Suppose I want the boat to land directly across from its starting point. What direction should I point? Which way is the river pushing me? So I think I'm going to have to point the boat northwards somewhat. I think it's going to look something like that. Maybe steeper, maybe shallower, I don't know, but something like that. And I can tell you how fast that is. Assuming I'm going to keep that boat speed the same, that's going to be 9.83. But the current is pushing me south. I'm going to combine my engine velocity with the current. How will I combine them? How will I add them together? Why, I think I'll draw them tip to tail. And this would be an impossible question if I didn't know what resultant I want. I want a resultant straight across the river, which means I'm going to draw the current exactly that long. What was the current? 6.88, thank you. And the resultant is from the tail of the first to the tip of the second. So the resultant is not always the hypotenuse. Often, usually, but here's an example where the resultant is the leg of a triangle. VR for resultant. And I guess theta is going to go right here. Color, 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 color. A asks what direction? Opposite. Hypotenuse. Sine? Yes? Mystery angle. Theta equals 6.88 over 9.83. And I get 44.4. North of south, east of west, what of what? That's got to be north of east, looking at my picture, right? Yeah, I got to point to the north to cancel out the current pushing me south. And then B, what will the resultant vertical velocity be? Well, VR squared is going to be 9.83 squared minus 6.88 squared because it's not a hypotenuse. It's going to be the hypotenuse squared minus the leg squared and then square root. 7 point something. 7.02. Just out of curiosity, how long would it take me to cross the river now? How wide was the river? I've scrolled down. What was it? So if I go 320 divided by, and I can do that because this is also a horizontal velocity to go with a horizontal distance. It would take 45.5 seconds, so it would take a little longer to cross. About an extra 10 seconds, a little more than 10 extra seconds to cross, but you don't have to walk all the way back. Example 3. I like example 3, I like example 3, I like example 3, example 3 is it. I also like example 1 and 2, example 1 and 2, I like example 1 and 2, they're nice questions. So, newsflash, on your test, there's going to be either a river question or an airplane crosswind question. Depends which version of the test I give you, but I've got about 4 or 5 different versions. There's always one of those on there as a written question. Okay. An airplane is flying through a wind. The wind blows due east. Nice try. The airplane wants to fly due north. What should the airplane's engine velocity be? Magnitude and direction. Well, V engine plus V wind, V ground. I think that's from your formula sheet, yes? Is that okay, Logan? Logan, what's this asking me to find? Get the engine velocity by itself. Okay, so you're telling me that V engine is going to be V ground minus V wind. Ooh, how do I subtract vectors? What do I do instead? Plus the opposite of V wind. Okay. What do we want the ground velocity to be? Direction? What's the wind velocity originally, magnitude and direction, Logan? So what would negative wind velocity be? 60 meters? Okay. There, I've turned my subtraction into an addition. Any thoughts on how I might want to add these together? Really? Okay, so 260, and then 60 is actually only about a quarter of that, so I'll draw it short so I'm roughly to scale. I guess this here is how the plane wants to point itself and how fast it's going to need to go. And this would have been, before we had GPS and the software, back in the 50s and 60s when jet airliners were just becoming a thing, you had a navigator in the cockpit as well, or a flight officer, they were often called. And they would be running these numbers, crunching these numbers. The better they were, the more fuel they could save because you could make the trip shorter. So they were worth the money. Where's theta going to go? Top left or bottom right? Bottom right. Color, 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 color. Well, let's find the magnitude. You know what? Solve this on your own. I'll do it here. Is that right? So there's a nice application of what we've learned so far. Vectors, how to add them and how to subtract them, and how crosswinds or rivers work. I think that's the last one. Yes, it is. First of all, what's your homework? Am I going to assign all of these? Let's see. Let me go through them. 1 is easy. You can do that almost in your head. Same with number 2. 3 is good. 4 is good. 5 is the same. 5 I'll skip. 6 I'll skip. Don't tell Parker. So 7 is better. That's a nice application. Skip 8. 9 is good. 10 is good. 11 is good. 12 is good. 14. I skipped 13. 15 is a little thought puzzle. 16 is good. 17 is good. And 18 is good.